So good evening to one and all. Welcome to the second day of the workshop on decarbonization of India's transportation sector. So today we'll have two sessions. The first session will be presented by Sri Rajarshi Bhar, so who is the research associate on this particular project, who is working on the development of the inventory data sets. And he'll be presenting the outputs that have been obtained during this ITF project. And the second session will be by Dr. Kutikunda Suresh, the founder of Urban Emissions India. He'll be speaking on the database development for the different emission components for the Indian scenario. So we'll be waiting for a couple of minutes for the participants to join. So, and I would request Sri Rajarshi Bhar to get ready with his presentation. Rajarshi.
Yes, I am ready. Like whenever you ask, I will share my screen.
You can share the screen. We'll be ready. So okay. We'll wait for 5 minutes. At 5:05 we can start the session.
Okay. Yeah, so is it visible?
So participants can ask you questions. Yes, it is visible. So we can have a formal interaction based on the yesterday's session. So any questions from the participants? So you can post them in the chat box so we can have few discussions. So any questions from the participants? So there are no questions. Then to a brief overview about the circular engineering group at IIT Kharagpur. We work on multiple projects associated with waste systems planning, waste treatment systems, sustainability systems, and trying to look at the circularity of the different products that we are getting. And wide variety of projects. It will include working on the smart cities as well as the smart city waste management systems, looking at how we can bring out the materials into the circular system. That means beneficial reuse that are coming out. So, and multiple research projects are being worked out on different treatment technologies like hydrothermal carbonization, leachate treatment using electrocoagulation, and fate and transport of different plastic and microplastics in the soil systems. And along with that, different life cycle data sets are being developed to develop the waste data set specific to the Indian context. So, and we are slightly moving on the development of looking at different Indian data sets with a very good amount of diversification in the systems, and trying to look at how we can make the linear systems circular in nature. So working on the urban system, diversification is primarily focused on the solid waste management, and looking at the integrated solid waste management with smart cities is one NPTEL course which Professor Jagesh is doing it for the past 6 years. Along with that, sustainability design and life cycle thinking is there. Plastic waste management, electronic waste management are the 4 courses which are being offered through NPTEL. Yeah. So that you can visit all those particular resources register to them, have a very good knowledge on what is happening over here. And similarly, the Circular Engineering Group at IIT Kharagpur, in collaboration with the Be Waste Wise, is organizing multiple seminars, which is being moderated by Professor Brajesh Dubey. So you can be a part of that particular sessions in the brainstorming in different issues that are there with the solid waste management. And similarly, you can put up different ideas over there, which will be helpful in strengthening the bonds of industry, institute, and governments. So this would be the brief overview of the Circular Engineering Group, which is being led by Professor Rajesh Dubey. So it's 5:05. I hope we can start the session. So I would request Mr. Rajesh Bar, who is a research scholar at IIT Kharagpur. So he'll be presenting the overall results that we have obtained, or the outcomes of the ITF IIT Kharagpur project, mostly on the biofuels components, the data sets that we are developing. So welcome, Rajesh. So you can start.
Yeah, sorry, it was mute.
Yeah.
So thank you, Dr. Ravi. I think my screen is visible. And
yes.
Okay, so I will start my session. Fine. So before straight away digging into the presentation, I would first like to thank my supervisor, Professor Bradesh Kumar Dubey, for setting the tone for this workshop in such a wonderful way as we started yesterday. You have first highlighted the significance of sustainability, how it is much more important from today's context. Then introducing the concept of life cycle design, then explaining how life cycle assessment works, and then how we can use the information that we get from these results and further design the product in a more sustainable way. Then it was followed by the talk of Dr. Ravi Shankar Chilla Reddy. So he had then much more focused on the transportation sector, not only just on the biofuels, but different components of the transportation and not just road. He gave us an overview of the entire transportation sector, including railways, roadways, airways, and showed us like how the footprint, how the population is impacting the transportation sector, how much GHG emissions are coming out of there. So after that, we had a talk from Mr. Samadar, who shared his views on how this going forward hydrogen energy based economy will push us to reach this carbon neutral targets, carbon zero targets, by exploring various options like electrolysis, water splitting to produce hydrogen, and thereafter using the same hydrogen to produce ammonia, which will be then used for as a fuel for different activities. So today, by working on the same platform that they have, the tone that they have set yesterday, today I'm going to present the work that is done by IIT Kharagpur along with ITF on supporting the life cycle assessment activities to decarbonize the Indian transport sector. Along this particular presentation, I will be sharing with you first a brief overview of how we and why we have to organize this particular workshop. What are the major points, major factors that are playing around that impact the road transportation sector in terms of the GHG emissions, and thereafter sharing some of the vital findings that we saw when we looked into the various life cycle activities of biofuel production, and in fact, this ICEV vehicles, how when they are manufactured and when the lithium-ion batteries are produced, some of those points as well. So moving on with the presentation. Okay. Yeah. So the first slide. So this slide, as you can see that the question I'm trying to ask that what has led us to this workshop. And I know that everyone can easily infer that the keywords that might be coming to your mind, those may be, yes, there's climate change, global warming, rise in sea levels. So all of these are the answers that has led us to perform or to organize this workshop. And already several studies have estimated that by the end of this century, there will be a rise in temperature of about 4 degrees centigrade, which will further obviously increase the temperature of the water bodies, which will further be a better breeding ground for various pathogenic organisms, and also does cause much more diseases and much more frequent diseases like malaria and dengue. Moreover, whenever the sea levels are rising, the coastal areas are getting inundated. So we see that associated migrations are taking place, which further cause various socioeconomic challenges. Uh, Apart from that, we see that due to this climate change, the places which used to be drier, they get dry, they are even more drier. The places which used to have some certain degree of rainfall, they are receiving much more heavier rainfall. Even due to this scarcity of rainfall at some places, the problem of hunger and famine, they are becoming much more severe. So all of these factors, they are having a huge toll on our mother nature. And as you can see from this particular slide, that by 2030, the deaths from just malaria, malnutrition, and such diseases are going to be about 2.5 lakhs, while more than 7 million deaths will be due to this air pollution. And apart from this impact on environment and the human health, we are also going to face a loss of about 2 to 4 billion US dollars by 2030. So all of this are some really motivating as well as alarming factors that we should really work towards decarbonizing our environment and our this mother earth as a whole. So in order to do so, first we need to figure out how this GHG emissions and how this environment is getting affected and getting warmer, what the pattern is, then only we can address what should be done or what is needed to be done. So in this particular slide, you can see that from 1990s, the data is shown here, but in fact, you can understand that this rise in greenhouse gas emissions, it began much more earlier, right from the start of industrial revolution. And then after, it just kept on increasing. And today, as per this particular graph in 2019, the total GHG emissions were about 50 billion tons of carbon dioxide equivalent. While if you focus on this right-hand side, this particular pie chart, it shows the distribution of the emissions coming from different sectors. This 31%, which is the highest, this one is coming from electricity and heat energy, these power sector, you can say. While the next highest is the transportation sector, which as you can see here, 15%. So both of them are the very significant contributors to this global GHG emissions. So it is vital that we address this transportation sector as well. In fact, going forward, the estimates suggest that as we move to 2030, then 2040, the presence of EVs in the market, it is going to increase. So as EVs are going to increase, I will in fact show you few data, few graphs in the upcoming slides, that as EVs increase, so will the power demand as well. So in that case, we can see that this 31% may further rise to maybe 40%. And although that emission may not be directly reflected on transportation, but you can of course say that this increase is an indirect impact of increased presence of EVs in the market. So in this particular slide, the same thing, the GHG emissions, this you can see will be talking about the developing countries like India. You can see that in our country and in places like China, who are developing as of now, who are about to reach the apex, due to this developing nature, this increase in GDP, we are seeing that yes, our GHG emissions, it is continuously increasing because we are yet to reach that point. While the countries who are already developed, like the European Union, various European Union countries, and then US, they have already apexed their GHG emission peaks. And then you can see that their emissions, it is kind of decreasing thereafter. Similar is for European Union, while for countries like India and China, we have an increasing trend, and that is, of course, a very expected outcome. So even though it is expected, we are not supposed to appreciate it. We are not supposed to push it. In fact, we are supposed to tackle it and address it in such a way that we can meet our net zero carbon emission targets. So in this particular slide, the same thing is shown in a more summarized way. You can see that currently China is the largest emitter with 26%, followed by US, and then India stands at about fourth position with a 6.5% of contribution to the global GHG emissions. Whenever we are talking about these emissions, when we think that yes, what solution we can look for, we have to first see that why are these GHG emissions there. So mostly we know that these are basically due to the combustion of fossil fuels, utilization of fossil resources. So whenever from our primary classes, our schools days, we have been taught that yes, we should go for renewable energy, clean energy, green energy. So, but these terms have been frequently used, maybe sometimes synonymously, but before digging deep, I would like to just briefly touch upon these. Like when we talk about renewable energy, it simply means something that we can get from nature and that can be replenished at a rate which is higher than what it is being consumed at. While if I talk about the clean energy, it's the name itself means that it should be clean. When you are using this energy, there should not be release of any unwanted pollutants into the atmosphere. While when we talk about the green energy, green means nature. We often denote nature or synonymously use green with nature. So these kind of energies are directly related to nature or from natural resources like hydropower, bioenergy, geothermal energy, and all. Then in next slide, here is what an ideal combination should look like. For example, renewable energy is this blue color and green energy is a subset of renewable. Not all the renewable energy sources can be termed as green, while at the same time, not all the green energy sources can be renewable. So we have to look for an option that is renewable, preferably green, but definitely it should be clean. So this particular overlap, this is what we are looking for. And this on the right-hand side, this can be how we can kind of jot it down in our memories to correlate these terms. Now, since we are particularly interested from the road transportation area, so I would first like to relate how this presence of vehicles will be there in India as we move forward. In this particular graph, you can see that going forth, our GDP is continuously rising. So there is a subsequent increase in the presence of these four-wheelers as well, because it is an obvious thought. We have more money in our pockets. Of course, we are going to buy a four-wheeler. But interestingly, uh, you can see that the presence of two-wheelers, it is at apex at somewhere around 2035. Thereafter, it falls, but the four-wheelers, it continues to increase. So that is one interesting observation that we can have in our mind. And followed by another graph that shows that this the presence of four-wheelers, different kinds of four-wheelers. You can see that during this COVID era, there was a kind of sharp decline in it as expected, less money. So the markets are not that good. As of now, also it is the same, but as the markets recover, as the GDPs is recovering at a faster rate, so does the presence of these four-wheelers in the market as well are going to increase. And then if we dig into what is going to fuel these vehicles, then we will see that in here BAU means business as usual. If the things keep on going as they are now, we will see that this 92% is basically liquid fuel, which is fossil-based liquids. Today, around 92% of it is present in our market. And by 2050 also, if things are going on as they are today, you will see that these are done by different studies. But basically, if you want to get to a concluding remark, you will see that majority, if we don't do anything, we will have the presence of fossil liquids like petroleum and diesel. And we all definitely know that they are having a huge impact on our environment. So as a result, we need to tackle this. This is also another way of representing the same thing. Today, we are having almost more than 99% or maybe more than 90% presence is from oil only. And as we go forth, you can see that this huge chunk, will be coming from electricity, while this particular yellowish kind of thing is from bioliquid, which can be bioethanol, biodiesel, while this greener one, it can be some other electric fuels like that. This is another estimation, which is not for business as usual. It shows that when we go forward and we are going to have a significant share of electric vehicles in the market, then we will see that today, I am talking about 2030. Let's say in 2030, I am saying that there are 53% presence of this electric vehicles in here. Then in 2040, it shoots up to 81%. Then in 2050, it is going up to 91%. Subsequently, the presence of fossil liquids, they are also falling as we go forth from one decade to another, and the CNGs as well. So this is what we are going to expect as we move forward. Now, coming to have a first notion about our country, where we stand. To get a brief idea, we have the second most, we are the second most populated country, third largest importer of crude oil. And out of all the diesel that we are importing, of it 70% goes into the transportation sector, and more than 99% it goes into of the petrol, it goes into the transportation sector as well. And when we talk about the GHG emissions, then overall India has more than 4 billion tons, out of which around 10% comes from the transportation sector, of which 87% it comes from the road transportation alone. So clearly road transportation is having the highest impact. So we definitely need to address that. In order to address that, we have various solutions that comes to our mind. Few of them are biofuels. We can shift towards biofuels, maybe EVs, go for hydrogen energy, design a vehicle in a more better way so that it has a lower footprint, prefer walking or cycling over using vehicles, other motorized vehicles, and promoting public transport, and maybe optimizing vehicle routing as well. So what in our study, what we did is that we looked into various LCA studies, basically focusing on the Indian scenario, which looked at the vehicular footprints, the footprint of vehicle manufacturing, their end of life. And our particular focus was on the biofuel component, to be precise. And in terms of biofuel component, from when they are cultivated, if, for example, if I'm using Jatropha for producing biodiesel, we will start looking at right from the cultivation phase to the phase from where the biodiesel is produced after transesterification. So, and this particular process, we are looking at it from a life cycle assessment perspective. So I would just briefly give you an overview of what life cycle assessment is, although this was taken care in detail yesterday also, but just to just go over it, I will just share a few points. One of them is that life cycle assessment, what life cycle assessment is. It is basically a tool, a technique through which we can determine the environmental footprint of a process, a product, or an activity for a certain duration. It can be throughout its life cycle. It can be for a part of its life cycle. But when we are going to address or we are going to perform life cycle assessment, it has got various fragments. One of them is the goal and scope. It begins with the goal and scope. We need to be very sure about the goal and scope. We need to identify what the purpose of doing a life cycle assessment is, who are targeted audiences, what is the functional unit, what is the system boundary. Like these are some of the commonly used words, commonly used keywords that we often hear when we are doing life cycle assessment. After we are sorted with our goal and scope, we need to build an inventory. And inventory is basically a database where, not a database actually, inventory is basically a table where we feed all the inputs and outputs that are there in our system that we want to analyze in terms of, you can say, like what amount of chemicals I'm putting into a system, what amount of emissions or any other waste that are coming out of the system, that particular mass balance, the flows should be there. Similarly, the energy balance should be there. What amount of energy is being consumed? If we are generating something, what amount of energy is being generated? All of these inputs and outputs from a particular system, they have to be fed into the table. And based on this particular data, we then analyze this environmental footprint of a particular system by using various assessment methods, like Recipe 2016 is a very common used one. Impact 2002 plus is the eco indicator. I think another one is there. So there are various life cycle impact assessment methods. By using those methods, we get the results, and then it's not just that we can get the result and we can just put it somewhere. We have to interpret it, we have to draw some conclusions, and then based on those conclusions, we have to put some recommendations as well, like what we have to do in order to address the environmental hotspots that we are looking at, like how can we reduce the footprint. So these kinds of recommendations are to be provided whenever we are performing a life cycle assessment. So that is one thing. So now moving on to the scope of our project with ITF was that we basically mostly looked at the biofuel component, particularly bioethanol and biodiesel, looking right away from the cultivation phase to the biofuel production phase. We didn't look into the combustion of the biofuel along with maybe a blending ethanol with petroleum and then combustion phase. We were not interested in that. Our scope was limited to the production of the biofuel. While when looking into the vehicular component, we looked into ICEVs, that is internal combustion engine vehicles. We looked into their manufacturing, their assembly, then delivering it to the market, and finally their end of life phases. While in terms of the EV sector, we were more focused on, to be precise, we were focused on the lithium-ion batteries, the footprint they have for their manufacturing and maybe end of life also. Then this particular thing, as I have already mentioned, why we performed this entire activity, the reason was that we wanted to build a database. There are already various established databases which we refer to often when we are performing LCA, but those are mostly for European or maybe Western nations which have a well-developed database from where they can refer to. But in Indian context, we are still in a stage where we are making our database really strong so that whenever we are doing some LCA studies in terms of Indian context, we can look for those particular data in this database and can build a life cycle assessment system that is more reliable, having less uncertainty and all. So this is really important so that we have our Indian database of our own So that is what IIT Kharagpur is doing for this biofuel production, and similarly for this vehicular component as well. Secondly, this particular data set, it is to be integrated with a GREET model, which is specifically designed for addressing the impacts of the transportation sector on this global warming as well as the energy footprint. So this entire thing is to be fitted into the GREET model and its system boundaries. Secondly, another scope that we have is the capacity building, then engaging with different stakeholders, and then making a kind of awareness campaign by using workshops and webinars like this one. Maybe we will share our views with all of the participants, registrants who are here, and maybe we can discuss with you and learn something new from you as well. So that is how we are trying to go forth by have a knowledge sharing session, increasing our awareness like that. And just since we are going to integrate it with GREET, I will just give you a brief like what GREET is. GREET is basically an abbreviation. This is a software that simulates the life cycle assessment or runs this model, and is developed by Argonne National Laboratory. And the full form of GREET is, as you can see, the greenhouse gas regulated emissions and energy use in technology model. This is the full form, and it simulates the emissions that are coming out from a certain vehicular model, and then the energy consumptions as well. And the kind of model it uses, GREET, you can see that it also includes right from the farming to the biofuel combustion as well. When we started looking into various studies based on Indian context, we found that on the left-hand side, this is for biofuel. We found that 19 studies we identified for the Indian scenario on biodiesel, and for bioethanol, we identified 70. While this vehicular component, it is more of a growing area. We are every day seeing new research, new work being done in this particular aspect. Same is the case for India also. So we particularly identified, we didn't see as much studies for biofuel as in vehicles. We particularly identified 2 such studies in India, particularly focusing on this vehicular in ICEVs and lithium-ion batteries area. The rest, we have to adopt some studies from China, Spain, US to kind of get a comprehensive overview where we stand and where they stand. It's like that. And somewhere we and China, since kind of similar scenarios, we saw that both of our results were kind of similar. Then this is the same, like when we are collecting the data for biofuel, we were very careful to record the data for fertilizer that is being used in cultivation, pesticides, diesel, electricity, because they often tend to have the huge chunk of global warming footprint. And while for a vehicular component, we looked into the lifespan of the vehicle, lifetime of the vehicle to be precise, then the lifetime mileage, the various components of vehicle and their individual weights as well. And then when we want to have a representative footprint for bioethanol production, like we had a number of studies, and there is one inherent challenge of LC is that it is often difficult to compare these studies with each other. So we identified few studies which can be comparable. Then we saw that there are different kinds of allocation techniques each study is adopting. We thought that yes, economic allocation is one such allocation which is really important and significant as well, and also has some certain appreciable amount of results so that we can come at an average value. So when we looked into it, we saw that the average fossil energy from well to tank means we are just producing the biofuel right from the cultivation stage to the production stage. It was around 0.16 megajoule per megajoule of fuel production, while the overall energy intensity was 0.35 with a well to tank GHG emissions of 19.64 gram CO2 equivalent. But this was for molasses and sugarcane based bioethanol. When we looked into lignocellulosic residues like others, like you can say rice straw, rice husk, cotton stalk, like that, they had a lower this GHG emissions as compared to the molasses and sugarcane juice. The reason behind this is that when we are cultivating sugarcane, the main product is of course sugar, the sugarcane juice, while molasses, which is also produced, it is having a much higher economic value as compared to that of rice grains and rice stalk. So that is why when I segregate the impact of this cultivation stage based on the economic values, a higher chunk of impact is bound to be provided to this molasses due to the high economic value as compared to rice stalk. So that is why this molasses-based ethanol tend to have higher GHG footprint as compared to other lignocellulosic residues. And the same I will also share with you with a case study that I have in this particular presentation that can make things a bit more clear. And when I wanted to draw some conclusions, like we have three phases: bioethanol production, cultivation, and collection and transportation. Basically means I have to collect the feedstock from maybe a farm and then transport it to a refinery. So among them, bioethanol production had the highest, followed by cultivation and followed by the collection and transportation. But this was the scenario for all the cases except for sugarcane based ones, like sugarcane molasses and sugarcane juice based. As I have just explained, if we are looking at sugarcane molasses, the cultivation will come at top and bioethanol will have the second seat in terms of the GHG emissions. So one such, just give me a minute. Yeah, this is one such case study where you can see that the system boundary is being shown here, where the sugarcane farming is taking place, then it is transported, and finally it reaches a refinery where ethanol production takes place, then it is transported to another place where it is blended and finally combusted in automobiles. In here, you can see that sugar is formed here and molasses goes forth. So this is where the impact of the cultivation phase, it gets distributed between the two and a huge chunk goes for the molasses as well. So that is why it often tends to have higher footprint than rice has. Then it goes forth and through the ethanol production phases and then maybe storage or transportation. And if we look on to the next slide, yeah, this is what the footprint looks like. Here you can clearly see that this farming phase, the blue color indicates if we are not allocating any impacts. The orange is for mass-based allocation, gray one is for energy, and yellow for market price or economic value-based allocation. In all the cases, except, in all the cases, you can see that this farming phase, it is having the highest impact on GHG footprint terms, in terms of GHG footprint, as well as in terms of energy consumption. So in both the cases, farming is the hotspot that we are looking at, followed by the production of phase of this bioethanol. Then in this particular one, you are looking at, you are looking at rice straw. In here, the rice straw is a feedstock, and this particular study is adapted from a IOCL study who have looked into various pre-treatment techniques to identify a environmentally favorable one or to determine the environmental footprint. So they have the rice straw, they collect it, pass it through various pre-treatment phases, then produce the ethanol for further use. So when we looked at, and in here, you can see that the system boundary begins at feedstock collection. There's no feedstock, like you can, there is no need to put the rice cultivation as such. The reason behind this is that I will show you here is that this study has particularly said that straw is a byproduct of rice cultivation and is considered as a waste. It can be a bit debatable, and if at all we are not going to consider it as a waste, if at all we provided some allocate some impact to this rice straw, it will be a much smaller one than what we saw in molasses. So that is why this particular study, it assumed this to be a waste and didn't add the cultivation phase into the system boundary. And when we looked at its footprint, you can see that the ethanol production basically includes extraction, pre-treatment, this hydrolysis, fermentation, and electricity use. And the feedstock collection and transport, it is this colored one, this bluish one, which is this. This is just a minute fraction of it, much smaller, while the huge chunk of it, it is being covered by the production of ethanol. So that is why I said that when we are talking about lignocellulosic residues, in those cases, the ethanol production stage, it is the one that is having the highest impact. And the cultivation stage, it often takes the backseat. Now, going on to the feedstock, we tried to rank the feedstock kind of based on the current trends or economics. In those cases, we see that both in terms of the current market trend and economics, we saw that molasses-based feedstock is preferably or is being preferred there. And if you look from a government policy-based one, then they are preferring the use of damaged food grains or surplus rice or maize. But if we go for such direction, then there is another debate that comes into picture, that is the food versus fuel debate. Whether we should store this rice, this maize for further feeding our population, or we should just simply use this to produce fuel. So that is a very important debate that goes around. So it is therefore wiser to find some other sources of feedstock for producing bioethanol and maybe biodiesel as well. So this is how this goes. And we found that molasses is currently the most preferred one, followed by sugarcane juice, syrup or sugar, and then damaged food grains, followed by lignocellulosic biomass residues. And coming about to biodiesel, in biodiesel, it had an overall fossil energy footprint without allocation was 0.52, and when we allocated the impacts, sorry, without allocation, the GHG emissions was 43.72, and after economic allocation, it was brought down to 30.78. And while the energy intensity was 0.51 megajoules per megajoule of biodiesel production. And these were the major feedstocks that are kindly being preferred. First is the palm-based, followed by jatropha, then karanja, then neem and mahua. These are the most frequently used feedstocks for producing biodiesel. And when we specifically talk about the GHG footprint, then we see for biodiesel, cultivation stage is having the highest impact, just similar to the molasses-based bioethanol, followed by the production and collection and transport. But this particular condition stands true for all those processes where we have to cultivate a feedstock like jatropha. But same is not the scenario for third generation feedstocks like microalgae and yeast. In those cases, biodiesel production is having the higher footprint, followed by cultivation phase. This is another case study that we had considered in our study, where biodiesel is being produced from microalgae. One set of microalgae is being cultivated using fresh water, while another one is cultivated using wastewater. In here, you can see that when we are going for fresh water, we are adding DAP, diammonium phosphate, we are adding urea. These are nutrients, we are adding carbon dioxide. But this is not the scenario for wastewater. We are just adding wastewater, some electricity and tap water. The reason being, wastewater already has some dissolved nutrients, so we don't need to externally feed nutrients into the system. On the other hand, in freshwater, there's a certain lack of nutrients. That is why we have to feed it. And please mind it that whenever we are feeding this this nutrients, this urea is also a fertilizer. So these all have a very significant environmental as well as energy footprint. So that is why when we are using these, there is a huge jump in the footprint as well that I will show you in the subsequent slides. After cultivation, we it goes through flocculation, then centrifugation, then we extract the required thing and then transesterified it to produce biodiesel. And for this particular system, 1 kg of biodiesel was produced for all these mass flows that is shown here. And when we looked at the results, we saw that this FW is fresh water, WW is wastewater. And in here, GWP, FDP, these are all midpoint impact categories. GWP is global warming, FDP is fossil depletion potential, and then STP is human toxicity potential, then FETP is ecotoxicity potential, freshwater ecotoxicity, like that. So we are mostly concerned about these two, GWP and FDP, and in here you can clearly see that when we are using fresh water, it is having a much higher, cultivation is having a much higher contribution to the overall impact of global warming as compared to the one of wastewater. See, this blue colored one is more than half, less than half of it. So that is clearly due to this use of some external fertilizers, external nutrient source, external CO2 is also being added. So due to all those reasons, while this yellowish one, that is extraction, which is a component of the biodiesel production phase, it is having then the second highest footprint in terms of this overall GHG emissions as well as overall energy footprint of the microalgal biodiesel. Then this is a better representation of how much energy is being consumed. In here also you can see that extraction, that is the production of biodiesel phase, this is where the huge chunk of electricity is consumed. Then this is another case study that uses microalgae in raceway cultivation ponds, after which it is harvested. Again, the same thing occurs, and finally it is being combusted in engines. Here also the same observation was verified, where we saw that this cultivation phase is having the highest environmental footprint as well as the highest fossil depletion. So that is what signifies the importance of this cultivation phase and the need to make it more environment friendly, make it more carbon neutral, or maybe reduce its carbon footprint. This was yet again another case study. Let me see. Yeah, this is for jatropha. So jatropha is a feedstock that that most of you must be knowing that we cultivate. This is a crop kind of. So we cultivate it, then we harvest it just like maybe any other crop. then it goes through those oil extraction processes, and finally biodiesel is formed. Similar to our previous observations, in here also cultivation emerged to be the highest impacting one in terms of GHG emissions and fossil emissions as well, fossil depletion to be precise, followed by the what do you say, this biodiesel production processes, those technical steps that takes place. Followed by, followed by briefly touching upon the ICEVs. ICVs, since you already saw that we had a lack of data in terms of Indian scenario, because more and more research is being started or we are seeing coming around. So based on what limited information we had, we saw that in vehicle production system, the production phase itself, it had the highest footprint, followed by the maintenance one. While if we talked about the lithium-ion batteries, in there, the variation that we see in the GHG emission was around 14 to 47 gram CO2 equivalent emissions per kilometer of distance traveled. And this huge difference in the highest and the lowest, this maximum and minimum, it was basically because of the type of battery that we are being used. There are several kinds of lithium-ion batteries, and based on which type we are using, the footprint also varies. And then after going through this activity, we had this project goals where we had to collect data, engage with stakeholders, spread awareness, have some learn something new from each other. Then this was our goals. And then we performed this activity. We've identified few process hotspots. That was the cultivation phase for biodiesel, biorefinery for bioethanol, except those molasses. Then manufacturing phase of the vehicular component. Some of the recommendations that we can share is that, of course, 3G feedstock in terms of biodiesel, it seems to be promising. Then we have biorefinery, the process for bioethanol production, that is to be further refined so that we can reduce its environmental footprint. And then, of course, optimize modeling for vehicle and its maintenance to reduce its significant, to reduce its GHG emissions, energy footprint as well. And then one of the most important things, that if at all we are finding that at some particular activity is having a huge footprint or a significantly high impact, that should be recorded in a structured way. So the collection of data in a structured manner, that is absolutely vital in this activity. And that is what IIT Kharagpur is trying to contribute from its part. We are building a database in terms of Indian scenario so that it can be further used. People can rely on it to design life cycle activities in further days to come and build systems which are more environment friendly. These are some of my references, and please, I thank you all to be patient and hear me out throughout this presentation. If you have some questions, please feel free to ask.
So thank you, Rajesh, for a wonderful presentation. We have few questions coming up. If we can look on, it's like in the chart list. Ray was asking about the water usage data.
Yeah, so water usage, it was, although it was not the concern of our particular study, but while we were collecting data, we saw that, of course, water usage was a major factor in the cultivation stage as well, because, of course, that is where most of it goes into. In whenever there is an industrial process, we often see that that is where the process water is often recycled in various industries. So there maybe the problem can be addressed, but this cultivation is where the huge chunk of water is being consumed. We were more focused on the GHG emissions and the energy footprint. So that is what our main target was.
The next question is from Chintan. How do we account for soil nutrient and quality analysis in the LCA?
Okay, so this can be done, for example, how we do LCA. Like if there is, when we look for nutrients, we often look for NPK content. So what we do is that if you have a sample of soil and you have something else to compare it with, in laboratory, what we can do is that we can get some NPK content of them. Then we can develop a relation that yes, this much NPK content is there. So this, based on previous literature, we can relate it, how much of it can be used. So comparing NPK content of two soils, we can just put it into the inventory and then further use it. So it comes into play when we are developing the inventory. So the amount of NPK we are getting, we can replace it with the subsequent NPK, synthetic NPK requirement. So that is how it works. For example, one good one can be, for example, in composting, In those cases, we often use biochar or hydrochar for soil amendment, and various studies, they already subsequently use it as an avoided burden for fertilizers, because when we are using hydrochar, we reduce the dependency on fertilizers. So that is how it helps in LCA. We are substituting one thing with something else.
Sir, will you add any points to this particular one? Sir, I guess we might be busy.
Yes, Ravi, yes. You're saying something? Ravi, can you hear me?
Yes, sir, there was a
Yes,
question. Yeah.
So there is a question in the chat box. How do we model soil, nutrient, and as well as quality in the LCA models?
Soil, nutrient, as well as quality.
Yes, sir.
So again, it like what we want to like what is the objective? What is the goal and scope? Whose question is that? Can we have that person unmute? And
Sir, it is typically where since we are using bio-based components, so in the farming activity and the cultivation activity, so we have soil interaction with the nutrients as well as the quality components are coming. So how do we model the soil nutrients in the LCA system? So that's the question, sir.
I don't think so. The present LCA system does that. As far as I know, they don't do that part. They are like what we try to, if he's talking about the impact of the fertilizer on soil that is used for this biomass generation, is if that's the focus. So whose question is this one? Can we have that?
Chintan, sir.
Chintan, yeah. Can you unmute? Can we unmute and ask that? I'm a bit confused what exactly you are referring to.
Yes, hello. Thanks for the lovely presentation. So the question was pertaining to, since we spoke about the overall impact from fuel generated from mostly from molasses and sugars. So that is particularly the question was about that, because we know that when the substrate is rice or any other food grain. So in that case, there would be a certain calculation that we could account for because a certain amount goes for food. But in case of molasses and or sugars, then how do we account for the land usage and also the soil quality or the nutrient net content of the nutrients? That is what my question was. And like you said, that maybe it's out of the scope of this particular study. Yeah, I understand.
It is out of the scope of this particular study, but yes, I can understand what you're talking about. So yeah, but yeah, basically, I don't think presently it is being accounted for in any of the study that we have looked at. Rajeshri may want to add if you have seen something on that.
Sir, what I understood is that how we are going to account for these fertilizer or nutrient quality of the soil. So whether or not this can be modeled in LCA. I think this was what the point was. So if this
yes,
is the,
that was my point.
Yeah. So one thing is that if we look into the system, we already know one way how we can do it is that we already know how much fertilizer that soil needs. And for that amount of NPK, urea, diammonium phosphate, and all, we already have databases present which we can look at to find the background footprint for those data. For example, if you are using 1 kg of urea, you can feed that into the inventory, and when you operate the particular software, and refer to a background database, maybe let's say EcoInvent, then in those cases, we have this background impacts already fed into the system. So from there is one way how we can get that impact of using a certain amount of fertilizer. Another way is that, for example, if we strictly look in terms of maybe some aerial emissions, let's say GHG emissions. So these NPK fertilizers often tend to have huge or significant N2 emissions, which is a huge or very significant GHG gas. So in those cases, let's say that a certain amount of NPK fertilizers is emitting X amount of N2 emissions. So when you are introducing that, you can directly feed that for the past 10 years or maybe 1 year or 2 years, this amount of N2O is getting released into the atmosphere. So you have to dig into very minute details while preparing that life cycle inventory. So the deeper you analyze it, the deeper you can fill it into prepare the table and feed the inputs and emissions. So that is one way, I think, how we can model this use of various soil quality nutrients or fertilizers, like those things. So that is one way how we can tackle that.
Thanks, Rajarshi.
You're welcome. Yeah. So I can see that there is another question, that is, what kind of challenge just anyone will face while collecting data? So that is basically, if you look into this question, challenges for collection of data. This can be particularly talking from Indian scenario. Getting data in Indian scenario, it is very difficult because, for example, as a part of this venture with ITF, we had to interact with different, or we have to interact with different industrial partners so that we can go to them, we can get data from them and analyze that data, and let's see that what we are looking at in the different studies, what that footprint is, and let's compare it to what we are collecting data personally and compare both of them. So we have already talked to several industries, and some of them, I will not reveal it under this platform, but some of them are very big names, also very big players. So they are clearly reluctant to share this particular data, because if we, due to some reasons, if such information goes into public platform, this can be some sort of threat to those industries. So that is why they are often scared to share this particular kind of data. So that is one aspect which is really, really challenging in terms of Indian conditions. Another is even at times not just related to LCA, for any other waste management challenges as well, that I think Professor Dubey will be better equipped to address this question, that collecting data for various solid waste characterizations and ones, they are there, but they need to be more structured and more in a more better structured way, like that. So this can
Can
be
you?
done.
Yeah, so can you hear me?
Yes, sir, you're audible.
Yes, sir.
So the question was on looking at data for solid waste. Is that?
No, sir, it is in general that what is the challenges in collecting data from Indian scenario, like that.
Okay. So in terms of yes, like data is a big problem in many developing countries. Also, sometimes in the developed countries, like you will have the data quality is always an issue. Collecting good quality data and LCA without data, like I do, you may have heard, those of you who have seen our YouTube video of the course that we have. At several points in that course, I keep on highlighting that if one thing that we need to worry, if three things that we need to worry about doing LCA is data, data, and data. All three are data. So we have to make sure that good quality data is collected. And in fact, the next presentation that we have is also on data in terms of air emissions data, that what Dr. Sarthak Kuntikunda will talk about that. He'll probably join at any time now. And we will have him. Yeah, he's already there in the list. So he will be talking about data too. So it's a data in all sectors, whether we talk about water quality, wastewater, solid waste, or any environmental data, even non-environmental data, like a different data quality. Having good data quality is very, very important. And we have seen, as Rajarshi was also mentioning, that it becomes a challenge. In fact, when we try to do LCA, many times the way the data is available, it's not as in that format in which we need it for doing LCA kind of exercise. That was one of the reasons why we are doing this exercise, where we are trying to come up with the database that we are generating mostly from, these are all mostly from secondary sources, so from published papers and reports, but that also try to match it in the format which can be used. So it can be the similar format as the brief model, so that it can be incorporated in the brief model. So that's those things is being done. So yeah, that's what I would like to highlight on that. So any other question left?
Sir, I think that was all.
No, sir.
Okay. Okay, so I think Dr. Sarath Kuntikutta is already here. And
can you hear me?
yeah, we can hear you.
Okay.
So Ravi, if you can just introduce
Yes,
just briefly, you don't have, if you introduce him full, it will entire 1 hour will go because he has done so much work. So just very in a brief way, just
Yes, sir.
introduce Sarath, and then the floor will be his. Yeah, please go ahead.
So, participant, we are ready with our second session now. So, the second session we have Dr. Sarath Guttikonda. He is an IIT Kharagpur 1997 alumni, atmospheric scientist, and founder of Urban Emissions India. His main research interest is air quality analysis and finding ways to bridge the gap between science and policy. He was a member of India's Air Quality Index Formulation Committee 2014, Special Advisor to the Ministry of Health and Family Welfare's Air Pollution and Health Steering Committee 2015, a member of WHO's Air Quality Guidelines Development Group 2016 to 2020. He received his PhD from the University of Iowa in the year 2002 and currently serves as an adjunct faculty at IIT Delhi's Trip Center. He is a recipient of AGU's International Award 2022, given annually in recognition of furthering the earth and space sciences for the benefit of society in developing nations. He is the second Indian to receive and the first Indian to receive in this particular category. So we welcome you, sir, on board, and we hand over the platform to Dr. Sarath Guttikonda to share his knowledge and expertise.
Right, thank you, thank you. You can see the screen in full mode. Okay, all right.
Yes, sir.
This is partly very similar to the presentation I gave last time, but I tried to update some of the new information that we have collected, not only for cities, but also at the national scale, and give you a flavor of some new things that are already happening, which might be useful for some of the work that you are doing as well. So there are in two parts. First part, I will focus on the transport interventions that were done in Delhi, which should be useful because we're also doing some scenario analysis to have an understanding of what is already done, what worked or what didn't work, and what kind of metrics are there that can be used further for some of the new analysis as well. And then second part, I'll focus on some of the data resources that we have for building transport-centric emissions analysis for India. So the Delhi paper, this is actually published, this was published last month. This has been in the making for a very long time. We wanted to review it and get it done out in 2020. But things got delayed for whatever reason, and every year new reviews come and it got extended. So in February, this is published. It includes all the information that we know of for Delhi from 1990 to 2022. And I'll focus primarily only on the transport sector, but I really push the idea that you should go and check out the paper. It's long, but it's quite useful, I feel. In Delhi, transport is still considered one of the main contributors to air pollution, irrespective of what you find in the studies, whether it's an emission-based study or it's a chemical analysis-based study or any kind of study that you see published in Delhi. Contrary to whatever it says, transport is still perceived as the main contributor to air pollution problem. Okay, the dots that you see on this graph are actually the maximum that the studies have established for each of the sectors, and you will see the transport sector it goes from 20 to 30%. Even a study done by the Central Pollution Control Board themselves in 2010, published in 2011, the lowest range is actually 9%. So they basically said that the range of transport contribution could be from 9 to 21%. So this is based on chemical analysis based source apportionment, which looks at source profile, biosignatures for petrol and diesel and gas, and then they statistically account for each of the sectors. So even though it's only 9 to 20%, the perception is that the transport is contributing almost close to 80% of the problem. If you compound transport as the key sector to almost every sector that you can think of, then it might be true. But going by the fuel signature, In Delhi, it is anywhere from 15 to 30%. Even this is the latest system that is actually running in Delhi. It's called Ra Asman, and it basically gives you real-time air pollution source apportionment. This is again a chemical sampling-based assessment looking at fuel signatures. So even here, they post it every day, and even here, you will see that the transport, the vehicle exhaust contributions is about 13% here, 11% here, 25% here. Now I made these slides yesterday, so the current one is not here. But if you go to the website, and you can see now what is the contribution of vehicle exhaust in the last 1 hour to Delhi's monitoring point, and wherever this is being monitored. The system was launched in January. Even the National Clean Air Program, which was launched in 2019, which required every non-attainment city to come up with their laundry list of action plan. What do they want to do in the city to control the air pollution? You will see that Delhi's action plan had 92 points, and 38% of those action points were directly towards transport. It includes everything from road construction to road maintenance to vehicle maintenance to PUC, promoting public transportation, NMT, all kinds of things. So in general, they mentioned that 40% of your even action points, irrespective of what the cost may be, cost percentage probably is a lot more, is still transport dominates. Household cooking, on the other hand, which when you start looking at the chemical signatures, is actually anywhere from 30 to 50%. Now, in the winter time, it actually really jumps up. But the kind of focus that you have in the action plan for household cooking is really, really small. So this is one of the points where we really have to concentrate on the data itself, on the sources, on the emissions, so that when even the action plans reflect what we are seeing on the ground. So this is something that we are pushing through the NCAP, and we are reviewing all the action plans and trying to put a spin on, we have to start focusing on the non-transport sector as well, as much as we are doing on transport sector. Delhi generally benefited a lot over the years. Any Bharat standards that were introduced in India, Delhi actually had those interventions, had those standards introduced at least 2, 3, or 5 years before they were introduced nationwide. And only the last BS6, the vehicle standards were introduced nationwide at the same time, but even the fuel standards were introduced in Delhi at least 2 years before they were introduced nationwide. So in general, Delhi always had had a benefit of the new technology, new policies, new scenarios, and that's one of the reasons why it's also one of the most studied city in the country. And looking at the air quality data itself, this is a compilation from 1989 to 2000. Sorry, the numbers should have been different. This is 1989 from 2022. And you will see that we really didn't have a good understanding of the baseline for a long time. The kind of amount of information that was available over various decades was very, very different. In the 90s, this is the only information that's available as an annual average only. And there were some manual stations running in the 80s and 90s, and they were only always PM10 based. And even before PM10, it was all total suspended particles. And that we basically used that to derive what could be the PM2.5 fraction. And then this is the big intervention that was introduced in Delhi, the CNG conversion for buses and taxis and three-wheelers. And there was a drop in the concentrations for PM2.5, and which can be directly linked to the CNG conversion, because the fleet averages really dropped in those couple of years. And again, the only reason why we can directly associate that drop to the conversion is because this data in this period comes from only one continuous monitoring station at the income tax office in Delhi, which is a very transport heavy junction. which means that if there is a change in the transport, in the fleet average emission factors, that will definitely be reflected at that monitoring station. And we are basically seeing that drop, and that basically gives us a little bit of hand waving confidence to say that the drop is actually associated with that. And after that, there was not so much action in Delhi. I mean, the number of vehicles have increased, the sales have increased, especially cars, motorcycles, everything. And the conversion that happened, it was only for a limited number of fleet. And that fleet never increased in size. No, the number of buses which were operating in 2000 in Delhi were 3,000 buses. And even today, the total fleet operating by the Delhi Transport Corporation is only 4,000 buses. So the fleet never really increased. So we never really got the benefit of having a clean, more expanded public transportation system. I mean, there was a clean public transportation system, but it was never expanded to gain more benefits from it. So from 2006 onwards, the push for Commonwealth Games came in, and there were more continuous monitoring stations being set up. Those slowly increased. And currently we have, Delhi has about 40 monitoring stations, continuous monitoring stations. So there is a drop in the last 3-4 years in the data that we are seeing. But one of the things that we are not sure of is if this drop is because we have a lot more data and a lot more representative data coming in from the city, or is the drop really happening because there are some changes happening in the behavior or something like that. But on a larger picture, there are no big interventions that were introduced in the last 10 years. So we really don't know how to interpret the big drop there. But the good sign is there's, at least from the ambient monitoring data, there's a lot more data coming in. This has a lot more spatial signature that can be further used for analytical purposes. There was this odd-even experiment that was introduced in Delhi in 2015-16, and they also did it in 2 times, in 2015 and 2016. But it was a very, very ad hoc intervention. They basically introduced the scheme, but with a lot of exceptions, which means that almost 85% of the vehicles were exempt. The motorcycles were completely exempt. Women drivers were exempt. The car had kids, they were exempt. Any car with official tag were exempt. Any vehicle with CNG was exempt. So there were a lot of exemptions. So in general, there was some change visually because there were lesser number of vehicles on the road, so the speeds were much better. But if you look at the data in different buckets, if you look at hourly basis, looks like there was a drop. But if we look at a daily basis on a 24-hour average, when there was no drop. So what we were thinking is people basically staggered their travel patterns because the restrictions were only from 8 a.m. to 8 p.m. So you basically stay in the office till 8 p.m. then leave the office after 8 p.m. So there was, in fact, the nighttime levels were a lot higher during the odd-even scheme than on the normal days. So overall, from the data perspective, we feel that the scenario was not, the scheme was not a successful one. But when again, it's from the one pollutant perspective, change that to CO2, one would say that vehicles were moving at a much faster speed. There was less congestion, so there should be your fuel efficiency has definitely increased, so there will be benefits on the CO2 side. So the conversation could be slightly different when we change that angle. The BRT itself, we know that it actually is a really good intervention, but in Delhi, it's a failed intervention because the original plan was only for 14 kilometers, but implemented only for 6 kilometers. And there was a lot of back and forth between the designs and what was implemented. And there was no true communication between the road users and the public transportation system. So there was always chaos, even in the BRT lanes, but eventually it got dismantled. But while this was happening, but for 2010, Delhi did use that concept, and about 80 kilometers of the roads were cordoned off for moving only the athletes and the officials, and using just cones. Now, there were no separate lanes built, but between all the venues and all the places where athletes and officials were staying. About 80 kilometers of road was cordoned off like this, and it was a really good success. I think the only reason why it was so successful is because it was also enforced with enough police and security to make sure that the other vehicles were not coming in, and vehicle movement, at least especially bus movement, was really free. So if implemented properly, enforced properly, obviously there is an example here that we can definitely replicate on a much larger scale, but this is something that has to be explored in a future scenario. I mean, this definitely has big benefits for air quality, but also for CO2 as well. The metro rail system definitely had a huge impact in how the way people were moving. Currently, it has about 390 kilometers of rail system, covers 286 stations, and the current capacity is about 6 million passengers per day. 6 million passengers per day. So this is now at par with what was before COVID. I think before COVID was around just about touching 6 million, and then everything went down. So now it is at par with the 6 million passengers per day. And there was a survey done by the IIT Delhi staff, and looking at what people are using to come to the stations and then leaving the stations. And about 50% of the trips are still an empty. And the remaining 50% are is a mixed bag of taking the three-wheeler auto rickshaws or personal cars coming in, motorcycles. And now, especially in the South Delhi area, the electric three-wheelers are definitely becoming a big thing, but they only have a capacity of about going around in a 2 or 3 kilometer radius, so they don't go really far off. So it's really interesting to see that a behavioral change in people taking the metros is definitely is limited to the area of 2 or 3 kilometers around that station. And then how do we expand that to a much larger or larger audience? Another good example is the Freight Expressway. These are the Eastern and the Western Expressways. They were introduced, they were opened up over three years ago. Each of the sites is about 135 kilometers. And the studies that were done before the expressways came in, they were looking at about 130,000 heavy duty vehicles coming into Delhi at that point. And if you ask them a question, this is the survey done by the Center for Science and Environment. If they asked questions like, no, are you delivering any products in Delhi, or are you just passing through? So at that point, about 50% of the traffic was really passing through. So, so now that 50% of the traffic which is passing through is actually using the expressways. It did make a good dent in the central, especially the nighttime air quality levels, because through Delhi, these vehicles can pass through only after 9 p.m. and they have to stop operations at 6 a.m. So it made a big dent in the nighttime concentrations. So generally speaking, of the transport emissions, these heavy duty vehicles are responsible for 30 to 50%, especially when they're all diesel based and they're all loaded. So they basically have a much higher on-road emission factor compared to a standard emission standard that they might be bought at. So generally speaking, those are the big interventions that are happening. This is the last one. In case of Delhi, they're really aggressively promoting the EVs. And they're hoping that about 25% of the new sales in 2024 will be EVs. And we are seeing a similar trend in other cities also. So on a life cycle basis, we will still see that I mean, since majority of the electricity is coming from coal, the benefits are like here and there depending on what studies that we are looking at. But at the city scale, there is a shift obviously in if the total number of vehicles on the road are going to be clean, we will definitely see a big jump in the overall vehicles. But I mean, this is new sales of 25%. So this is not the fleet percentage is only about 2%. So it'll take some time for us to see a big drop in the fleet averages, maybe in about 4 or 5 years. So these are all the new things that are happening, or old things that have happened in Delhi in the last 30 years. But one message that is very clear from all this is, if we really want change in air quality, especially on the downside, we want to decrease in air quality, that decrease is going to come only if we drop the emissions at the sources. I mean, it can't be these interventions like putting up a smog tower or sprinkling water on the roads or having these mist guns and things like that. That's not going to really help. We really have to go after the sources, and they have to cut down emissions at the sources. So the COVID-19 example is a really good one. So this is a synopsis of the satellite feeds over Delhi's airshed, and the drops for PM 2.5 and NO2, which were more likely to be linked to the transport sector in those days, was huge. And I mean, a lot of other sectors were also down. The power sector was also down. Industries were closed. A lot of cooking, both residential and commercial sector were off. So there were a lot of other activities also happened. But in case of NO2, it's a very, very transport heavy pollutant. And there was a big drop, almost 50% drop over the Delhi's airshed. So which means that if we cut down direct emissions, we will definitely see a big jump in air quality levels. So the same concept that what we have doing in Delhi, we're also doing very similar work in other cities as well. We've put up this baseline information for almost 50 airsheds, which are also online on our website, and we are also building a lot of resource material that can be used for further analysis. Not only for cities, but also at the India scale as well. So I'll quickly go over some of these resources that are available for the transport sector. While I'm focusing on transport sector, like Brajesh has mentioned at the beginning of this presentation, so we're not focusing only on transport, we're also focusing on non-transport sector as well. But I really won't go into the details of that. But if you go through our website, you'll find a lot of these very handy if you're interested into that. So for the transport sector analysis, we are looking at basically 3 different buckets. One is the supply side, how many vehicles are there in the system and how much are there. And the demand side, how many kilometers are they traveling, the usage part, and the emission factor technology. And how do we, combining these 3, we have the emissions. The equation is very standard for whether we're talking about air pollutants or we're talking about CO2. So we can mix and match all the numbers and build a story depending on what our endpoint is. A lot of the work that I'm showing you is actually done by some of the colleagues at IIT Delhi, by especially one of the new assistant professors, Rahul Goyal, and some of his students. So the vehicle types, especially that means the number of vehicles and also different types of vehicles. Most of this data that we are using was originally built for the NTTPC Commission, in those days Planning Commission, now it's Niti Aayog. And this is where a lot of massaging has to be done. Again, a point that Brajesh mentioned before is that none of this data exists in the form that we want, that we can immediately use for analysis. Even, for example, if you go to the Ministry of Road Transport and Health, Ministry of Road Transport and Highways, they will have a total annual registered vehicles numbers. But if you look at a file which is from 2018 and you look at a file from say 2000, they don't match. They won't match in the times in the vehicle types mentioned. They won't match in the spatial segregation that are there. So you really have to now go back and see, okay, what can we dissect and what can we segregate to make a story a lot more smooth flowing. So a lot of work had to be put in just to smooth things out, so we can have a very simple story to tell for each of these vehicle categories. Generally speaking, if you look at the vehicle registration numbers, there is obviously numbers are growing. There's no doubt about that. But some sectors are growing much more than the others, and there is a little more flat lines in some cases. For example, the flat line thing is mainly for buses. Like we want more public transportation buses, but there is no the way they expand, the bus fleet expands is not the same way as the personal vehicles is. The black line is 4-wheelers. I mean, they have increased 2.5 times, but the buses have really gone up to like 1.1. I mean, this kind of differences when we really need to address if we want to really decarbonize the entire sector. In fact, in the new IPCC report, one of the action items, which basically says that you will have a lot more benefits at a lower cost, is by pushing a public transportation system. And I mean, this is something that we are not really doing it to the fullest extent. And this is a quick look at what the fleet size would be or growing up, depending on just looking at the current sales information and then projecting it forward, and looking at total registration numbers only. So this is as reported by the Ministry of Road Transport and Highways. And there is always a 2 or 3 year backlog in the data that you get from the Ministry of Road Transport. It has been the case for a very long time. Only recently, the Vahan website has come forward, which basically posts almost on a monthly basis at the RTO level, how many vehicles are being registered. So these will be new registrations or even second-hand registrations all combined. So they basically call it as a new registration. So even there, we really have to take it with a pinch of salt. But one of the advantages now we are seeing in Vahan website is they are giving information also on the fuel breakups, even on the engine sizes as well. So this is something that we can use going forward. But all the data that's available now, it's only from 2016. It doesn't go before that. And also the data is not immediately accessible. Again, when we can only download RTO, one RTO at a time, 1 year at a time. So we really have to go back and forth and trying to find a way to bridge that data access gap. So this is where I mean, if any of the students listening to this, if they really want a very challenging exercise, and this is really one of them. Collecting all the information that's there on one and making it available for other researchers to use. So the next challenge that comes in is to convert this registered information into in-use vehicles. So basically, what we want is what fraction of these vehicles are actually on the road, and they are the ones basically contributing to the problem, whether it's air quality or for the climate change. So we really don't want, if there are 100 vehicles registered, but there are only 50 vehicles are in use, I mean, you don't want to do the calculations for the 100 vehicles, because then you will really overestimate the size of the problem itself. So even here, converting this registered number of vehicles to in-use using survival functions was a big challenge, because when we can't just borrow a survival function from EU or US or even China and see that if it works or not, so it won't work for us. Because when in general, in India, we use our vehicles as much as possible. I mean, they may not be used by one person directly, but if a person is moving to a second vehicle, the first vehicle will definitely be in the market still as a second-hand vehicle, whether it will be in the same city or go to a different city, but it will still be in the running. So we really want to understand these in-use vehicle characteristics and survival functions, both at the city level and also at the national scale, with how long they survive. So this is where we tried to come up with some new survey programs in trying to understand the in-use characteristics of these vehicles. And the survey form was very simple. We first tested this in Delhi, and then we tested this in about 10 other cities across India, some tier 1 cities, some tier 2 cities, and some tier 3 cities. And basically, we ask a very simple 3-point question to the person filling any of the fuels in the gas tank, and the survey literally finishes in about 2 months. And the person has some extra questions, we take those, because most of the time they are curious to know why we are doing this, so we kind of explain that. And there are some questions that we note while the survey is happening. So every survey will have 2 students, and one student is basically noting down all the passive questions, and then one person is doing the active questioning. I mean, we don't really have to ask the person what fuel are you pumping, because we can see whether it's gas or petrol or diesel. We can note down the registration number, we can note down the occupancy number, we can note down the vehicle type. So in this sample that we use in Patna, I mean, there are only 6 categories listed here, but we later on increase this to about 10 different categories. The three questions that we ask are basically the vehicle manufacturing year. If they say it's from 2010, then we know that it's a 13-year-old vehicle. We ask for mileage. It's an estimate. So they can basically tell us, oh, I get now 10 kilometers per liter or 20 kilometers per liter. Sometimes they tell us that if I don't run AC, I get 25, but if I run AC, I get 20. So we mark down those ranges. So it helps us in later on building what kind of variations are we seeing in the fuel efficiencies. And the odometer reading, same thing. So if the odometer reading says 13,000, and if the vehicle is 13 years old, then we basically estimate, okay, on average, the vehicle is being run for 1,000 kilometers. It's very small, but that number can range quite a bit. So the process has been really easy, and it was easy to explain it to students, and we were able to quickly implement it in a number of cities in building these sort of survival functions and some usage functions. For example, in this case of Patna, we were able to do this exercise at 10 different stations. That was about 10% of the mapped gas stations in the city. Randomized across. Some were industrial hubs, some local, very rush centers, and some were outskirts and residential areas. So we randomized the station locations. In about 10 days, 19 students, we were able to collect a sample of 10,000 surveys. And the mix of vehicles that we collected is like this. 40% of the mix was motorcycles. And because everything was being collected during the daytime, and the nighttime we put them into the app. We use the ODK, which is a free app to upload all the information from the surveys. So we basically told the students that they can't go home before they enter everything. So that basically gave us some understanding of what kind of vehicles are coming to each of the different stations. Are we able to catch a good number of sample in each of the categories or not? So if one surveyor captured one day only motorcycles at the gas station, then we basically tell them next day that, look, you can't do only motorcycles, then you have to do some cars, or today you focus only on cars. So we were able to give some real-time next day instructions to the students in getting that done. So here, a quick look at the cars. For example, the average fleet average age came to about 6 years, and this is a tier 2 city. In case of Delhi, this was 4.5 when we first did it in 2010. In about 2016-17, it was when it was redone. It came to about 4 years. So obviously, a tier 1 city has a much a different profile compared to a tier 2 city, and we've done this experiment now in Gaya, Muzaffarpur, Indore, Visakhapatnam, Rajkot, and Udaipur, and a couple other places. So it really helped us try to understand a good mix of the in-use profile of the vehicles. And the maintenance itself, so this is something that we have not much to talk about. The pollution control program is there. It's only a certification system where every vehicle has to go through, and they get a certificate. But the testing that's done is really, for lack of a better word, it's a bogus test. And this idling test, where a probe is put into the exhaust, and they take some measurements for CO as a index. And VOC, it's a very old standard, and pretty much every vehicle passes. The failure rate in Delhi is about 2%. This is something that we've recently done, looking at PUC data from 900 stations for all of 2021. So the pollutants that we're really interested in, the PM, NOx, SO2, CO2, they are not measured. And none of these tests are on chassis dynamometers, so we can't really associate them with real world driving conditions. So this is a system that really needs some extra work. And if that is not done properly, I think this is Dieselgate-like scandal is pretty much ripe to happen in India as well, because we don't really test the vehicles for real world emission factors. So we don't know whether a vehicle is actually complying truly to its standard or not. I mean, every vehicle has a sticker, but we don't know the true compliance of them. The emission factors, so this is a big black box at the moment. Very few tests have been done. Ideally, tests should be done in real world conditions on the like onboard, using onboard equipment, or you bring the vehicles to a testing location where you have a chassis dynamometer running a representative driving cycle, and you take the measurements. But the very few of those are happening. One big pool of tests that were done were in between 2006 and 2010 by the Central Pollution Control Board as part of the 6 city source apportionment study. But the sample size was only 250 vehicles. I mean, for a fleet size, which is almost 250 million vehicles, testing only for 250 is not really a useful sample. Having said that, this is a new study that's being done by ICCT. They're using remote sensing and looking at all the pollutants. The study is actually underway right now, and they're hoping to finish it by end of April. And the pool of vehicles that they are looking at is about 100,000 in Delhi. So we are really looking forward to like what will come out of this work, because especially because of the sample size, it will be really great to have that information. And they're looking at the on-road measurements. So we are looking at now real-time vehicle exhaust. So it will be really good to see what comes out of this. So they say that my ICCT says that all this work will be public domain in May or June. So let's keep our fingers crossed that will happen. And the road network itself, once we have these numbers and we're calculating the total amount of emissions that are coming from the fleet, we really want to know the next step is where are these emissions. For this, having information on the road network is also very important. So we are using two different resources at the moment. So one is the OpenStreetMaps, which is free, but only thing is the big cities have a very detailed road maps that are like people are manually going there and marking out all the roads. So that information exists. But when you get into the smaller cities and the smaller airsheds, the information is very concentrated only to a small portion of the airshed and doesn't cover the wider picture of that. So that is there. And then the second layer that we're trying to compensate, which is a paid resource, is from Google Maps API. So we create a origin destination matrix within each of the airsheds, and then we try to pull data from the Google Maps distance API. Within the API, there is a small link for the road itself. So what we are basically considering that as the in-use roads. So there is, when we have a full road network information that's coming in, either from the local bodies or from OSM, that is there for use. But at the same time, I mean, this is where the Google says that people are using these roads more often. So this could be an in-use road network that we have. So when we're doing a spatial allocation of the emissions, we basically give a little extra weightage to grids with these roads identified than putting it in like all over the place. So it really helped us in getting a good spatial representation of the emissions in the chemical transport modeling of air quality. This is another example from Mumbai. We use this information, the speed information, especially at the grid level, for two different things. So one is if a particular grid is at a congestion scale, congestion level is under 15 kilometers an hour, we modulate the chemical signature of the emissions. So for example, your VOCs will jump, your CO will jump because the vehicles are running at under inefficient conditions. So that there will be a big change, a significant change in the VOC signature. So we were able to modulate that. And we also use the speed function to modulate the dust emissions. So if vehicles are moving at 10 kilometers an hour, then you can't have resuspented dust in the grids. So we try to cut down that. So we make sure that the emissions are not there where they shouldn't be. So we've done this for about 30 cities because it's a paid resource. We can't keep doing it all the time. So but we are hoping to do it every once in a while. We go and update these resources. So generally speaking, I mean, there's this a lot of data that's available, which needs to be massaged and which has to be put together in telling the story. And more data, if it's there, we'll definitely use it for more analysis. And as we're going forward, we can definitely use whatever happened in the cities, for example, in case of Delhi that we've seen. So all these different interventions were put together, from behavioral change to technical interventions. So we can definitely use some of those examples going forward to see which kind of intervention can work and doesn't work. And if it works, what kind of intensities are we looking at in the changes. So when we are doing some amount of work in the cities, which are loaded on our website. I encourage you to go there. And if there is a way to overlap some of the work that we are doing with some of the collaborations that you guys are up to, we'll definitely take it forward and see what more can be done. Yeah. Thanks.
Thank you, sir, for your valuable inputs and information on the database development for the emission modeling. So we have multiple questions on the chat box. So to start up with, it is Madhumita Patel. Can we use the Delhi data in other places for the transportation sector? Because location plays an important role. So that's the first question from her. Sir,
so for example, the CNG conversion program was a very successful program in Delhi, mainly because it was applied for the entire fleet. And there are some cities which tried to replicate it, and like Ahmedabad has done it, Hyderabad has done it, and even Panjim, Goa is trying to do it. But they're trying to do it in a very at a small scale, they're as a pilot scale. So we can't really see any significant benefits of that. So in a long story short, the kind of enforcement and the kind of implementation that happened in Delhi, it never got replicated in other cities in India. So conceptually speaking, the CNG conversion program is great. It will definitely works, but implementation is a really big. It's a big thing. But this is one of the things we actually highlighted that in the paper. A lot of intervention that happened in Delhi happened because Supreme Court really intervened, and Supreme Court said, "Okay, do this, and they got done." And the Supreme Court doesn't take the same kind of decisions for for other cities, and not really happening.
Sir, one more question from Madhumita Patel.
Okay.
How to change people's attitude to adopt public transportation?
I'm not a behavioral scientist, but I feel that the incentives have to be there. And again, one of the surveys that was done by IIT Delhi, key point that comes out from why you're not taking public transportation is safety reasons. Okay, if people say it's not safe for me, especially the last mile connectivity, or not staying at the bus stop and not knowing whether the bus will come or not come, whether I'll get onto the bus or not. So these kind of issues, the punctuality, safety, reliability, these have been the biggest concern in almost every city, not just in Delhi. Similar surveys were done in Hyderabad, in Bangalore. Bangalore has the largest fleet, public transportation fleet in India. And even there, the same things keep popping up. So if we want to really change the behavior, we really have to cater to the safety, reliability, and punctuality of the system to the public, saying that when we will get the bus will be there, and there will be plenty of space for you to get on. Then we'll definitely see it. At the same time, I think there has to be more incentives. When we have some programs, for example, in Chennai, they give free bus rides for kids in school uniform, like free buses for people, the women working, especially during the rush hours. Those kind of programs have really changed for certain group of people, but something similar incentive should be given, and the fleet also has to increase. Then I think we'll definitely see a big behavioral change.
Thank you, sir. Sir, then question from Ray. what is the experience of the organizers or experts today in lobbying for the implementation of solutions such as those presented today? So even the IPCC recent reports give solutions that are so simple and doable, but we cannot move ahead in the absence of political will. So, Andy, can you share your experience?
I think that sums it very well. No? Political will. We need that. So even the simplest solutions that we have needs that political will. I mean, taking the same example as before, the last one is the public transportation system, right? It's like on the paper, it's the simplest solution there is. Buy 10,000 buses and put them on the road, and put some incentive program so people will take it. No, so it's very simple solution, but the political will has to be there. Right now, I think when there's more money being pumped into building roads and highways and the metros, and not much is going into the procuring buses. So it's really as simple as that. No, we need more political will. I think this is where I think programs like these can come up with material that can not only educate the students and the researchers and experts, but also politicians also. Basically saying that, look, this is the intervention. If you increase public transportation in the city, it's going to benefit air quality so much. It's going to benefit the CO2 signature so much. So maybe simplified messages have to be push to the political parties as well, so that they are also on board with the same messages that we are trying to put out.
Thank you, sir. So, Professor Brajesh, sir, do you have any viewpoints on this particular question?
The last one, you mean?
Yes, sir. The same question, the race question.
Let me. Okay, what the experience of? Okay, implementation of solutions.
Yes, sir. Implementation.
Yeah, as Sarat very in fact he also talks about there having the absence of political will. So he kind of answers his question by himself. Yes, we do. There is a lack of political will, and also that's definitely there. But see, as a citizen, we need to also push for that political will should happen. We need to give indication to the politicians are from among us only. So we have to give them indication that this is, if you do that, it's okay. It's that kind of message also has to go, because right now the lack of political will is mostly either through some fear of losing some votes here and there, or maybe some lobbying happening here and there. So those are the causes which causes the. But if you look at the CNG when it came in Delhi, was not very popular. All the hardship that it caused was because I was in Delhi at that time. I was working in Delhi at that particular time. I think 99. I think it was around 98, 99, that time period. And we had a lot of problems. Like our office was in Bikaji Kama, and the other office was in Gurgaon. We could not travel. A lot of issues were there. But then gradually people were happy that. So it does. Yes, some of the politician has to take some courageous decision to make it happen. But at the same time, I will say that they should also go by, although the question it says that we should go by the basic science, like as science should be there in policy making too. That should be, we should not go by emotions all the time. That there has to be strong science should be there in terms of whenever we make some decision. So, yeah, I think.
Thank you, sir. Sir, we have a question from Virab. For decarbonizing actions, the road-wise data with vehicle type is very much needed. Is it available at a state level or national highway level? Something like Department of Transport for UK has a website showing each of the automatic or manual count point, which becomes very much useful in some of the assessments. So the question is like, do we have the data of vehicle type available at our national level or state level, sir?
So at the road level, if you're looking for how many vehicles are passing through on a particular highway, or even within city on the main arterial roads or primary roads, that kind of information is not available. Some urban planners They do take videos and then count the vehicles and use it in the OD matrix calculations. But this doesn't happen on a regular basis to put that number together. But having said that, there's a group now in Bangalore which has come up with a really cheap 50,000 rupee box, which is basically it counts all the vehicles in real time and then relays that information to a central portal and do exactly what you're saying. Have a understanding of what kind of vehicles, how many vehicles, even NMT vehicles are passing through a particular junction. But I think this is a system in emerging mode, but we really don't have a centralized database, not at the city level, not state, not national level. No.
Thank you, sir. So the next question is from Kapil Meena. Can real-time information be important in reducing air pollution exposure? And like in China, after providing real-time information, air quality in China improved and people started avoiding travel, changing their departure times, changing their mode and exposure route, and changing their mode of travel. Is this also can help India as we require 4094 more continuous monitor? So it's a bit confusing in the question. So Kapil Meena, if you are available, kindly unmute and brief us what exactly the question is.
Good evening, sir. Good evening, sir. Sir, like in the China before 2013, there was a huge air pollution, but after providing a real-time information, people are starting changing their behavior. They are shifting their mode of travel. They are shifting to the less exposure route. But in the Indian scenarios, we have a very lack of real-time information. So, do you think so? This can be helpful because India, if we see the literature, only 24% people understand what is the significance of air quality. Like they don't even understand what the significance of air quality. They know this is good, bad, or poor, but they don't understand the significance of real meaning of the AQI.
No, certainly. So it's not only just the real-time information, but also having understanding of what is the air quality going to be in the next couple of days. That information, if information is available, like from the what we call as air quality forecasting systems, that can be used and preempt from that event happening. So China is definitely doing that, especially in Beijing and Shanghai. But more successful examples actually come from Paris and Singapore. So where they use the forecasting systems to the fullest extent. And if they see, for example, in case of Paris, the biggest problem is transport. So if they see that certain zones in the city are going to exceed the NO2 standards or ozone standards, and that are obviously coming from the transport exhaust emissions, and they know it because of modeling done 2 days in advance, they can cordon off vehicles going into that area, basically saying that if there are no emissions in that area, irrespective of what the meteorological conditions are going to be, we are going to prevent that event from happening. Okay, and when they take such extreme measures, they again incentivize public transportation system. The buses become free. The cycles, that Velop cycles that they have, they become access to them become free. So they do give incentives, saying that okay, we are restricting certain areas for personal vehicle movements, but here's a bunch of incentives for you to take free metro, free buses, and things like that. So that really helps. So not only having real-time information within the hour, it will be really hard to take action, but information is available at least 1 or 2 days in advance. We can definitely take action using that information. And it's when we have really good couple of successful examples. Only thing is we need to have a system in place to implement. I mean, that's where the enforcement is where we kind of lack. And that is something we have to work on.
Thank you, sir. So the next question is from Swasta Elangovan. Which air pollution modeling software like Caline 4, AirMod, do you think best represent an Indian urban road vehicle pollution scenario?
I personally don't use Callahan 4 on air mod because they're very linear and non-chemistry models, and we are a very, very chemistry dependent model system. Our environment is very chemistry heavy. So if you really want to understand urban air quality issues, when you really have to invest some time in running either CAMX or CMAC or WRF-Chem. That will help you not only do the emission scenarios, but also try to understand from the chemistry angle as well, whether it will help us in reducing the primary emissions and secondary emissions, and what kind of variations are we seeing for different scenarios.
So thank you, sir. So the next question is from Rajarshi. Which locations in India, other than Delhi, can be the benchmark for other cities to follow to reduce the carbon footprint of the transportation sector? Is the first question. And what are the steps taken by the authorities? Is the second one, sir.
I mean, the quick questions are, and I can go with a little bit of examples from different phases. So, for example, public transportation system in Delhi, the CNG conversion happened. It's a big example. There are other cities which try to replicate, and then they put their own twist on it. Like for example, Bangalore did it, Chennai did it, Ahmedabad did it, Hyderabad did it. So they didn't immediately go into CNG, but then they started looking into buying newer standard vehicles. Then they found out that no, you really don't have to change the fuel. If you get a newer standard vehicle, it's actually as equivalent to buying introducing a new fuel change. So they put a little twist into that. The paratransit system really changed quite a bit. In the beginning, even in Delhi, for example, there was a limit on how many three-wheelers can be registered. But after that was lifted, it made a huge change. And I think the similar examples were also used in a few other places as well. One thing that like, for example, when we're talking about carbon footprint, it literally means that if you don't burn fuel, your carbon footprint literally comes down. And then the only subsector that will help you with that equation is NMT, non-motorized transport. I think that's one thing we really haven't promoted well in any of our cities. I think Bangalore is really pushing that angle. But we haven't seen a similar push for NMT scenarios in a lot of other cities.
So Rajesh's connecting question is there, sir. In Tripura, the vehicles are run on CNG. Is it due to the local CNG reserves? So
that I don't know.
Okay, sir. So that's the questions from the chat box. So participants, if you have any questions, you can interact. We have 10 minutes of time. Sir, or Professor Dubey, sir, any viewpoints on this particular sessions?
Yeah, so I just wanted to ask Sarath, see when certain cities, for example, Melbourne or since I've been to these cities and lived for a considerable period of time and used the transport there. So, for example, Melbourne, the CBD area, you can travel for free on those that they have. It's kind of a metro tram kind of system. And same thing, not same thing, but in Toronto, actually, you don't need to have a car. Or maybe Singapore too. So in Singapore, what I may be wrong, but what I have heard from people is that Singapore, the car ownership has been made so expensive, so that it becomes people have to use public transport. So cities like Delhi, where we see so much of air pollution issues, also may not be that much from the vehicle. There are other sources there too. In fact, some of the malls are running on electrical gensets. Like we have diesel gensets running the mall. So those are also a problem. Dust is a problem. Nearby burning of fodder is also a problem. But still, can that kind of thing, can be made possible in India? Like can we, or what are the practical difficulties? Since you work in that sector, I just look it from a distance, but you are in there. So I just want to hear your view on that.
when the odd-even scheme was introduced, so that's the first thought that was on the table. This odd-even scheme will be successful only if there are alternatives. When we look at Singapore, when we look at Stockholm, when we look at London, even now Beijing, you really don't need to own a vehicle to move around in the city. And we don't have that system in place. So we did a quick calculation on if we have to cut down 50% of the vehicles on the road, how many minimum number of buses do you need on the road? So it came to about 13,000 buses, and Delhi operating only 4,000. And if you look at the white paper done by Central Pollution Control Board in 1997, right before the CNG conversion, so in that white paper, they basically say very clearly that in 2000, our travel demand will be so much that we need 15,000 buses. So the number is not coming from out of the blue. The number is there. But we never made effort to increase the fleet to that extent where a person feels that, okay, I don't need a car, I don't need a motorcycle. I just walk out, get into a bus or walk out, get into a metro and go wherever I want in the city. So the alternatives don't exist, and we haven't put enough emphasis on these alternatives. I think that's where we fall back.
And this electric vehicle that we have been talking so much on, when I look at from a life cycle perspective, the manufacturing of those batteries, we have to mine those metals to make those, and some of those are critical minerals, critical metals. They come from the geopolitical issues are also there, material security issues are also there. Then you use when you have to charge the battery. And yesterday we had one gentleman, he was telling that at some places they are using actually a diesel genset to charge the batteries of EV. So that kind of we completely lose it there. And then and then you have end of life of those. At some point of time, you have to worry about end of life. Same thing, you have to end of solar and other sources too. So, but when we make this policy, like that, having that holistic view, having that scientific rigor, you have like interacted with policymakers more. So I have also had some experience, but why we don't see that? It's not only India's problem; its problem is global. You find it other places too. Like, but how to make that, bringing that scientific rigor in policy making? Is it possible? Will it we see any day?
It's possible, but I think we really, especially I think politicians, they get scared with data. The minute you say data, I think they're just scared. The diesel genset example is actually true. I've seen it in action in Kathmandu. Like Kathmandu has so much power cut, and in Nepal, all of Nepal, the surcharge is 300% on any vehicle, whether it's a motorcycle or a car. So if it is for us, if you're buying for 20 lakhs, the same vehicle will cost 60 lakhs in Nepal. And now the new incentive that they have put in is the electric vehicles will be no surcharge. So basically, everybody started buying electric vehicles, but they have almost on average 12-hour power cuts. So this is in Kathmandu, you have 12-hour power cuts. So literally, they're running on diesel gensets. So you see them in a lot of places. So coming back to the data question, so I think it literally comes down to when we do all the science and we do all this big number crunching, we have to also simplify that information in a way that the politicians don't get scared of it. So and try to speak in that language, especially, for example, in air quality. The minute we say death or air quality leads to death, nobody wants to listen to you, especially in the political circles. So you don't use those words, even though it's in the back of your head. So you basically convert that into right now our city is only it's not compliant. Now we are not 10 times higher than our national standards, but now if we do 1, 2, 3, 4 actions, we will be compliant. then look, that word resonates with almost all the regulators. So because they want to be compliant. At the end of the day, that's what they want, like all the audit works and everything else. So I think we do the science, we make sure that we can defend every number that we are putting on the table, and basically use the right words with the right people to push the agenda, so they don't get uncomfortable listening to us, and then they themselves were comfortable in pushing it forward. I think this is something, a little push and pull has to happen.
Okay, and any question? Okay, I think we had good
And we're
interaction.
right on time.
We are right on time. So
Yeah.
we are right on time. So that's really good.
Yeah.
So yeah, so Ravi, you can wrap it up.
Yes, sir. Dear participants, the discussions, we wish to take it long and long, but at some point of time, we have to bring the ship onto the board. So this is the time that we are bringing our ship onto the board. And at this point, we would like to thank our Dr. Sarath Ji for taking his time out of his busy schedules and sharing his valuable experiences and expertises in development of data inventory databases specific to the Indian context. We hope to interact with Sarath Ji in the upcoming times in getting good amount of experiences that he is going to have in the upcoming years. Thank you, sir. And wrapping up this particular situation, and we'll be waiting for 5 o'clock tomorrow to have 2 more beautiful sessions. The first one is with the Sri Associate Professor Wahidul Biswas Ji from the Cotton University, who will be speaking on integrated framework to assess sustainability potential of alternative fuels from a life cycle perspective. And similarly, from the second session will be from the Associate Professor and Head of the Department, IIT Tirupati, Sri Dr. Krishna Purna Piligiri, who will be speaking on circularity in payment systems engineering. So, dear participants, so have a nice evening. Get recharged with tomorrow. Let's have this beautiful session and continue our discussion on decarbonizing India's transport sector. Thank you.